What's up, everybody? Mr. Kozad back again for another video lesson. This lesson is on Nth Roots, which is section 6.4 in our Algebra 2 textbook. So this is basically going to help us to figure out how are we going to find Nth Roots. What is an Nth Root and how are we going to find them? Okay. So what is an Nth root? Well, pretty much all of your mathematical career, you have dealt with square roots and maybe an occasional cubed root here and there. But we can actually take any numbered root of a number. Okay. So there's basically two different types of roots. You can have even numbered roots or odd numbered roots. Okay. And the chart that you see here basically walks you through all the possible scenarios. Okay. So if we split this into two different parts, we've got, like I said, even roots and odd roots. Basically, if I could summarize this in a way, it would be that if n is even, meaning you're taking an even root, like a second root, fourth root, sixth root, eighth root, or etc., you're going to have exactly one unique positive and one unique negative real root. So that's basically just saying that you're going to have the plus or minus. Okay. It's also important to note, this is just kind of a semantics issue, but the positive root is called the principal root. That's if you're taking the root of a number greater than 0. If you are taking the number of the nth root of a number less than 0, you're going to have 0 real roots because you can't take the even root of a negative number. Okay, let me show you some examples of what that means. So let's say I'm going to take the fourth root of 16. Okay, picking easy numbers to work with here, but the fourth root of 16, we're basically, what this is asking us to do is what number to the fourth power equals 16. And we know that we could rewrite that as the fourth root of 2 to the fourth, which would simply come out as a 2. Now what this whole column is really saying is if I ask you to take the fourth root of negative 16, okay, if I ask you to take the fourth root of negative 16, you can't do that in the real number system, so you would say no real solution. There's no real solution to this. It doesn't exist. Okay? So if we flip over, actually before I move on, so technically we could do plus or minus 2 to give us positive 2 to the fourth power equals 16, and negative 2 to the fourth power also equals 16. But most of the time when you simplify these, you'll only have the positive, which, like we said earlier, is called the principal root. But just keep in mind that it can be both a positive 2 or a negative 2 as your answer, which is different than saying you have a negative on the inside of a even root. Okay, if we kind of change gears a little bit and look at an odd root, we could say, okay, the cubed root of 27. Okay, cubed root of 27. Again, pick an easy number so we can deal with this. There's exactly one number that makes this true. There's not two options. Over here, remember that we saw that there was actually two different options for numbers that give me 16 if I take them to the fourth power. But when you have odd roots, you only have one option for those roots. So there's only one number that whose cubed root is 27, and that is 3. The only way to get 27 is 3 to the third power. Okay. Now, if we change that up and we said, okay, let's do a different problem. Let's do the cubed root of negative 27. Okay. If this were an even index, you would see this negative inside the radical and say, nope, can't do it, no real solution. But when we have an odd root, like 3, 5, 7, something that's odd, an odd index, you don't have to be worried about a negative on the inside of that radical. That's simply going to give us a cubed root that is negative 3. Because if you think about it, if we do negative 3 to the third power, that would be negative 3 times negative 3 times negative 3. Negative 3 times negative 3 is positive 9, but I still have to multiply by a third negative 3, which gets us to negative 7. So it is possible when you have odd roots to have to take the root of a negative number. It's not necessarily a problem. Okay? All right, so let's practice simplifying some of these nth roots. Okay, so here's two pretty simple problems. Okay, A is asked us to simplify the square root of 16x to the 6th. Now this should look really familiar to us because this is the most common root it's a square root. Okay. You obviously know if you see a radical without a index shown, you can assume that it's square. So we all probably know that the 16 is going to come out of that radical as a 4. Now let's talk for just a minute about the x to the 6th. Okay. Basically, the way you want to think about this is if this exponent is larger than the index, you can bring part or all of it out. So the next thing that I look at is I look at that exponent and ask myself, how many times does the index, in this case it's a 2, go into this exponent evenly? Okay, so if we take 6 and divide it by 2, we get 3. So what we can actually bring out of that is x to the 3rd. X to the 3rd comes out of that radical. So basically when you take exponents and bring them out, you're going to divide by whatever the index is. Okay, so the principal root here would be 4x to the 3rd, but the actual solutions, if you want both of them, are plus or minus 4x to the 3rd. Remember, principal root only means just the positive, but both of the possible outcomes here are plus or minus 4x to the 3rd. Okay. Okay, so here we go in part B. Simplify negative square root of the quantity q cubed plus 5 to the 4th power. Okay, now you might be wondering, what is the purpose of this negative out front? Well, that's just saying it wants the negative root of this answer. So it doesn't necessarily want the positive one, it just wants the negative one. It's kind of a silly semantic thing that your textbook does, but it is what it is. We'll roll with it. Okay, so what I look at here is I see that I have something that's being raised to the 4th power. Now remember that this index here is a 2. Okay, so you want to look at this exponent and ask yourself, is this larger than the index? The answer is clearly yes. So then I see how many times does 2 go into 4 evenly, and it goes in evenly actually 2 times. So what I can bring out of this equation is I can bring q cubed plus 5, keep that in parentheses, but it's going to come out as a 2nd power. Now throw a negative sign in the front because the problem specifically asked you for the negative root. Okay, so there is your final answer. Okay, so here's another one. Now we're actually looking at a 5th root. Okay, our index here is a 5, so we're going to do a little bit of work here. So some of these roots, what makes these kind of hard is some of you are going to have to do some number crunching to figure out what roots are. Okay, so off the top of my head, I don't know what 243 is a 5th root, but I'm going to take a wild guess and check on my calculator that it's 3. So I'm going to punch in 3 to the 5th, and there it is. I see that I have 243. So here's how I'm going to rewrite this. I'm going to rewrite this as the 5th root of 3 to the 5th, a to the 10th, b to the 15th. So then I'm going to take each one of these individually and see what comes out. Okay. Now since it is an odd index, you do not need a plus or minus in front of there, because if you have odd roots, you only have a positive or a negative, but you don't have both at the same time. Okay. So clearly 3 to the 5th is going to come out of that radical as a 3. A to the 10th, we look and we see that 10 is in fact divisible by 5. It goes in twice. So we have a squared that comes out. And then if I look at b to the 15th, 15 is also evenly divisible by the index 5. So that comes out as a b cubed. 3a squared b cubed. Okay. All right, next few problems. These would be good for you to pause here and try on your own to see what you can get. Okay, so go ahead and do that, and then start the video back up when you're done with these, and I'll go through them again. Okay, welcome back. Hopefully you paused the video and tried these on your own. We'll go through some answer choices here. Okay, so the 9 comes out as a 3. X to the 8th is going to come out as x to the 4th. This problem wants both the positive and the negative root because it gave us the plus or minus. Okay. Over here, we're going to leave the negative sign and we're going to bring out a cubed plus 2. And we see that 8 is divisible by 2, so it's going to come out as a cubed plus 2 to the 4th power. And then lastly, 32 comes out as a 2. X to the 5th comes out as just an x, and we have y squared. Again, I don't need a plus or minus in front of this because it is a odd root, and odds will either be positive only or negative only. Okay. All right, here's one that's a little bit different because everything's not going to just divide evenly. Okay, so take a second, write this one down, and we'll go through this. Okay, so 24 is not a number that's to the fourth power, but it can be written as a factor, it can be broken down so that one of the factors is a number to the fourth power. Okay, so let's see here. It actually can't be written as a number to the fourth power. Not that I can see, because 2 to the fourth power is, no, you're right, 2 to the fourth power is 16. Yeah, and 16 is not a factor of 24, so we're just going to leave the 24 alone. There's nothing we can do there. Let me clean this up just a little bit so people don't get confused. Okay, so we're going to just leave that 24. Okay, now let's look specifically at x to the 9th, y to the 7th. Okay, let's look specifically at those. Now, x to the 9th is not evenly divisible by 4, but it is larger than the index 4. So we're going to be able to bring part of that x to the 9th out. So ask yourself the question, how many times does 4 go into 9 evenly? If you said 2, you are correct. So what we're going to bring out is we're going to bring out not 1x, but we're going to bring out x squared. Okay? Repeat the same process for y. Ask yourself the question, why does 7 is clearly larger than 4? So see, how many times does 4 go into 7 evenly? And that's only one time. So we just are going to bring a y to the first power out of the radical. So then what we have left is we have some things that are trapped in the fourth root. 24, nothing I can do to simplify that. Okay. Now that x to the 9th, we brought, so 4 went into 9 evenly 2 times, and the remainder that you had is x to the first left over. And then for y, 4 goes into 7 one time, and you had y to the third left over. So that is your final answer. You're going to get a lot more practice with that part here in just a minute. So the last thing that we're going to do is here's a set of 8 questions that you can work on simplifying yourself. I'm going to go through each one of these, but I think it would be a good idea for you to pause this, work through some of these, and then come back when you're ready to see the worked out solutions to some of these. Okay, so pause the video now and then work, and then we'll come back together when you're ready to see the worked out solutions. Okay, hopefully you wrestled around with some of these. My theory is that you tried and you got kind of far, maybe to 5 or 6, and then you kind of click play because you got stuck on a few of these, or maybe you just have quit listening to the video. For those of you that are still with me, man, thank you for being with me. Okay, 24, square root of 24, that's an easy one. We can break that down to 4 times 6. And then we know that the 4 comes out as a 2, so that's just going to be 2 root 6. Number 2, the cubed root of 1,000, that's easy, that's just 10. Number 3 is one that you maybe had to do a little bit of work on, so you can rewrite that as the cubed root of negative 27 times 6. Okay. The negative 27 comes out of the cubed root as a negative 3. So that's going to be negative 3 times the cubed root of 6. The 6 is trapped there forever. Okay. Okay, number 4, we can rewrite this as 256 times 2. The square root of 256 is 16, so that gets me 16 root 2. And if this is going too fast for you, remember I asked you to pause this and work on these on your own. And if you're like, how in the world is he getting those numbers? Okay, literally what I did is I just used I guess and check on my calculator. I found some, I just worked my way up to get the largest factor of 512 that's a perfect square and simplified it from there. Okay, all right, so number 5, I did the same thing, but instead of looking at square roots, because my index is 4, I was looking at numbers to the 4th power. Okay, and on number 5, I got 16 times 8 is 128 times n to the 8th. Okay, 16 is 2 to the 4th, so 16 comes out as a 2. The 8 is going to be trapped forever, but then look at n to the 8. Remember, if this degree or this exponent is larger than the index, you can bring at least part of it out. 4 goes into 8 2 times evenly, so I'm going to bring an n squared out. And what I have left over in the fourth root is the fourth root of 8. Okay. Number 6 is the next one. 98 square root of 98k, so that's going to be 49 times 2 times k. 49 comes out as a 7. The 2 and the k are trapped, so that's going to be 7 times the square root of 2k. Next one, number 7, fifth root of 224 r to the 7th. What I was able to figure out there is 32 times 7 gets me 224, and we still have an r to the 7th. So 32 is 2 to the 5th, so that comes out as a 2. R to the 7th, I'm going to bring one r out, and I have an r squared left over on the inside. Remember, because when that r comes out, it comes out as an r to the 5th. And if you bring an r to the, it comes out as an r, but to come out it has to be r to the 5th. So you only have r squared left over on the inside. Okay, number 8, we could rewrite that as the cubed root of 8 times 3 times m cubed. 8 is 2 to the 3rd, so that comes out as a 2. M to the 3rd comes out as just an m. And I have the cubed root of 3 left over inside. Okay? All right, I think, 8 more for you to try. These ones are a little bit more tricky than the previous ones. So definitely pause this one here, work through these 8, and then get back with me when you get those finished. Okay, welcome back. You probably had a little bit more trouble with this set than you did on the last set. These ones took me a little bit more time to figure out as well. Again, it's not necessarily complicated. It's just some guessing and checking to try to find powers that work given the index that we have. Okay, so for a number 9, here's what I was able to figure out. Number 9, I did 196 times 2 x squared. 196 is 14 squared, so that comes out as a 14. X squared comes out as just an x, and I have a root 2 left over that stays forever. Number 10, again, number 10 was one that was a little different. We had, I think that's wrong. So I think that comes out as a 16x root 2 is what I think that comes out as, 16x root 2. Double check that one. I can't read my handwriting on that one, so that one might be wrong. Sorry if it is. Okay, but you probably have already figured it out why it's wrong. Okay, number 11. Okay, number 11, we've got the fourth root. So we're looking for numbers to the fourth power. So I found 81 times 5. 81 times 5 is what I found. Let me clean that up a little bit. 81 times 5 times x to the 3rd y squared. And the 81 comes out as a 3. And that's actually all that comes out. So there's nothing else. The 5 stays forever. X to the 3rd y squared. There's nothing you can do there because these exponents are less than the index. So there's nothing to do on that part. Okay. Number 12, negative 16 can be broken down into negative 8 times 2 times a cubed times b to the 8th. So negative 8 comes out as a negative 2. A to the 3rd comes out as just an a. B to the 8th, 3 goes into 8 2 times, so I bring a b squared out, and I would have a 2b squared left over in the radical. Okay, number 13, we could rewrite 13 as the fourth root of, I did 16 times 8, x to the 7th, y to the 7th. The 16 comes out as a 2. X to the 7th comes out as a x. Y to the 7th comes out as just a y. And then let's see what we have left over on the inside. So I have that 8 left over on the inside, and I have x cubed, y cubed left over on the inside. 14 cubed root of 16xy. I can do that as the cubed root of 8 times 2xy. The 8 comes out as a 2. And I have the cubed root of 2xy trapped inside forever. Number 15, I had to do some serious number crunching on number 15. So here's what I came up with, and you hopefully did as well. So 6th root, I was looking at numbers to the 6th power, and 2 to the 6th power is 64. So when you divide 448 by 64, you get 7. So that can be 64 times 7 times x to the 7th, y to the 7th. So the 64 comes out as a 2. Look at x to the 7th. 7 is greater than 6. So 6 goes into 7 one time. So you can bring an x out, you can bring a y out, and you have a 7xy trapped on the inside. And lastly, number 16, I got 56 to split up into 8 times 7, x to the 5th times y. The 8 comes out as a 2. X to the 5th comes out as x. And we've got some stuff trapped in there. We've got a 7 x squared y trapped on the inside. Okay. That went super fast, and some of you probably nailed it. You did great. It's awesome. Others of you are going to need to go back and maybe practice those 16 questions again. It's not complicated. The hardest part of this is just all the number crunching that goes into finding the particular roots, depending on the index that you have. Okay, so major takeaways. Remember that even roots can be your answers can be either positive or negative. But the rule with even roots is you can only take the even root of a positive number inside the radical. And then with odd roots, you don't have plus or minus in your answer, but you also are allowed to, on odd roots, take odd roots of negative numbers on the inside. That's not a problem. Okay, so hopefully this was helpful. We'll see you next time. Thanks.